Today we're going to be looking at Unit 7, Angle Relationships. So in the last lesson we looked at what makes up an angle and how we can see congruency inside of angles. Today we're going to be looking a little deeper into angles and the relationships that angles form. So we have complementary and supplementary. So complementary angles are two angles that add up together to give you 90 degrees. Supplementary are two angles that add together to give you 180 degrees. So complementary angles create right angles. Supplementaries create straight angles or linear lines. So we have some examples of complementary and supplementary angles right here. Our next idea that we're going to look at is perpendicular lines intersect to form right angles. So when we have two lines making a perpendicular intersection, then we have right angles that are created from there. And then all points and lines shown are coplanar. So G, H, and J are collinear. So if we have ray HM, ray HL, ray HK, and line GJ intersect at H. H is between G and J. So these are all that we can assume from this drawing. We can't assume that the lines appear to be perpendicular. We have to know that they are by that little symbol. All right, let's try an example problem. So find the measure of two complementary angles. So if they're complementary, that means that the two angles are going to add together to give you 90 degrees. So add to give you 90 degrees. If the measure of the larger angle is 5 more than 4 times. So we have a small angle and we have a large angle. So the small angle, whatever that is, that's going to be x. The large angle is 5 more than, so that'll be plus 5, 4 times the measure. So 4 times the measure of the small, 4x. So these two angles together give us 90 degrees. So this is going to be x, our small angle, plus 4x plus 5, our large angle, summed together to give us 90 degrees, our complementary angle. So what we do is we add our like terms together. X and 4x gives me 5x plus 5 equals 90 degrees. Subtract 5 from both sides. That gives me 5x equals 85. Divide both sides by 5. We get x equals 17. So that means the smaller angle has a degree of 17 degrees. The larger one's going to be 4 times 17 plus 5. Well, 4 times 17 is 68 plus 5 is going to give us 73 degrees. So our large angle is 73. Our small angle is 17. If we add those two together, we end up with 90 degrees. So tangrams is a puzzle consisting of several flat shapes called tans, which are put together to form shapes. So find the value of x and y such that line AD and line EC in the tangram are perpendicular. So we know that those two lines are going to be perpendicular, meaning that angle ABC equals 90 degrees and angle EBD is also going to be 90 degrees. So let's solve for y. So we know that ABC is 90 degrees. That means this is going to be 90 right here. This is going to give me 3y plus 15 equals 90. So I'm going to subtract 15 from both sides. That gives me 3y equals 75. Divide both sides by 3. I get y equals 25. Now I want to find x. Well, I notice that EBD is 90. Well, angle EBF plus angle FBD equals angle EBD. Those two small angles, so this angle right here, which is adjacent to this angle right here, those two put together give you the 90-degree angle. So this is going to be 7x plus 10 plus angle FBD is 8x plus 5. 8x plus 5 equals angle EBD, which we said is 90 degrees. Add your like terms together. So our like terms, that's going to be 7 and 8. That's going to be 15x plus 15 equals 90 minus 15. I get 15x equals 75. Divide by 15. X equals 5. So x equals 5 and y equals 25. So now we want to interpret this diagram. So everything, we're going to come back to this diagram and say if it works or if it doesn't work, just like that last little note that we had. So the first one, ray CE and ray CF are opposite rays. CE and CF. Yes, they are. C is the common endpoint. Angle BGC and angle KGC form a linear pair. So a linear pair means that they're going to come together to make 180 degrees. So BGC and KGC. So those two form a linear pair. Yes, they do. The non-common sides, meaning GB and GK are opposite rays. And that's why we have a linear pair. Angle ABJ, so ABJ, and angle CBG are vertical angles. So that means that this angle is vertical to this angle, and yes, it is. Formed by two intersecting lines. Angle BCG and angle DCF are congruent. BCG and DCF. Well, they're not vertical, so we don't know that they're congruent. So we cannot assume that. The angles are not vertical. If they are vertical, we could assume that. Line segment BE and line IF are perpendicular. So BE right here and IF. Well, we don't have that perpendicular symbol, so we can't assume that. It could be 89 degrees for all we know. F. Angle EBC and GBC are complementary. Well, we really don't have any measure of angles in this. And we also don't have any perpendicular signs. So since we don't have any measure angles and we don't have any perpendicular signs, again, as I said, it could be 89 degrees. It could be 91 degrees for all we know. So no, not enough information. And then G, ICH and HCD are adjacent. So let's look at ICH. So ICH and then HCG. HCG are adjacent. Yes, they share the common side. The common side is CH. And then BC is an angle bisector of ECG. So ECG, and then we said that BC, again, we don't know if it actually is or if it's just a line in between. There's not enough information. So no information given about congruent angles. So that is our lesson for today. Go ahead and write a summary down here at the bottom of what we covered, dealing with complementary, supplementary, perpendicular, and pulling information out of a diagram.